Hi guys, welcome back to Aisha.Academy. And today's a bit different because as you can see from my channel, I've got loads of GCSE content, but this is my first piece of A-level content, maths. And this will be going through the differentiation and integration topics from the 2021 assessment material because I know a few people have asked me, so I'm doing it for those that have asked and anyone else that's interested. Okay, so looking at question 1, it says given that dy by dx is equal to 1 over x squared, 1 over 6x squared, basically wants to circle the right one when it's integrated. So remember, if you see plus c, it's integration. So the first thing that we're going to do is rewrite 1 over 6x squared, which whenever you've got it as a fraction form, the power would become a negative power. So that's the same as saying 1 over 6 to the power of x to the minus 2. So now we have that in regards to integrating it. So if we were to integrate, that's the integrate sign, 1 over 6 x to the minus 2 dx, we would end up with, so remember with integration, you need to add 1 to the power and then that new power divided by everything. So then that would end up being 1 over 6 x to the minus 1 over minus 1. So anything divided by, if it's going to be divided by minus 1, that's going to end up changing it to a negative 6, and then x to the power of minus 1, and then plus c. Because remember, whenever you always integrate, you end up with plus c. So we can rewrite this actually to minus 1 over 6x, because we know to the power of minus 1 is the same as saying 1 over x. So then that would be that. And so the one that's closest to that, and then obviously our plus c, is this one here. And then having a look at question 3, it's given us an equation and it wants us to work out d2y by dx squared. So we need to work out dy by dx first and then differentiate again. So then I'm going to rewrite the equation. So in regards to this one, I'm first of all going to rewrite the 2 over x, because that can be rewritten as 2x to the minus 1. And then I'm going to change the x over 4 to minus a quarter x plus 1. So then now to work out dy by dx, so remember you have to multiply the power by the number in front. So 4 times 3 will be 12, and then you always take 1 off the power. So that would be cubed, and then that would be, so minus 1 times plus 2 would be minus 2x, and then minus 2, and then that would just be a minus quarter. The x is going to disappear, and the plus 1 is also going to disappear. So now if we do d2y by dx squared, we're going to differentiate the dy by dx. And that would give us 36x squared plus, because remember minus 2 times minus 2 is positive 4. So positive 4x is a minus 3. And yeah, that's that. And then the minus a quarter will change. So you can leave it like that, or you can write it in the proper format of 36x squared plus 4 over x cubed. Okay, so having a look at this question 5. So having a look at question 5, it wants us to differentiate y is equal to 4x squared plus x. So again, we're just going to do dy by dx. So then in this case, the power of the 2 times 4 would be 8. And then take away 1 of the power, it just becomes 8x. And then x is going to differentiate into 1. And that's literally that differentiated. And then question 5, I'm going to zoom this out and make some space over here. Not the first question 5, this one, the next one. Because we want to make sure we have enough space for working out. Okay, so we've got f dash x is equal to 2x minus 3 over x squared, and f3 is equal to 2. So it wants us to find what f of x is. Okay, so one thing I want to make clear is that f dash x is the same as saying dy by dx. So then f of x, which you may have been familiar with from GCSE, is the same as just saying y. So if you're now trying to work out what f of x is, to go from dy by dx to what y is, you need to integrate. So we need to integrate those brackets. So what I'm going to do first is I'm going to expand So I've got the 2x 3 over. So then that squared is the same as saying then multiply by each other, and then just expansion really of double brackets. So then it's going to expand to 4x squared minus 6 plus 9 over x squared. So then now that I have that, minus 6 and minus 6 will simplify together. So I'd end up with 4x squared plus 9 over x squared minus 12. Okay, so now that I have this, I want to integrate. So I'm going to end up integrating all of that. So before I integrate, I'm going to change the 9 over x squared into 9x to the minus 2 because we know that they're equivalent. So I just wrote that in the top in case anyone needed a reminder of that. So then now to integrate, remember we add 1 to the power and then that new power we divide it by everything. So then that's going to integrate into 4x cubed over 3 plus 9x to the minus 1 over minus 1 minus 12x plus c. So remember with integration, never forget your plus c. So then now that we have that, I'm going to simplify this all down into 4 over 3 cubed. And then dividing that by minus 1 would leave me with minus 9x minus 1. And then just remember anything, if it's x to the power of minus 1, that's the same as saying that over x minus 12x plus c. Okay, so now that we have this nice and neater, what we're going to do next is, so looking back at the top, so it said that when we substitute x as 3, we get an answer of 2 into the equation of y. So this is our y equation. So we need to substitute, so x is equal to 3. And when we substitute that in, we know that that's equal to 2. But then also doing that will allow us to work out what plus c is, so the equation is complete. So I'm going to change y as 2, and then I'm going to substitute x for 3, and then 12 times 3 plus c. Okay, so then that's all going to simplify down into 36 minus 3 minus 36 plus c equals 2, and then 2 is equal to, so 36 minus 36 is going to cancel out. Then you've got minus 3 plus c, so then rearrange that, c is equal to 2 plus 3, which is equal to 5. So we know that c is equal to 5. So the final equation for f of x is 4 over 3 x cubed minus 9 over x minus 12x plus 5. Okay, and then having a look at question 8, it did come up in a previous AQA past paper. I can't remember what year it is. I think it's 2018. For anyone that is wondering if they've seen it before or not. So in this question, it's basically given us a graph, so a logarithm graph, and it's given us the equation. It wants us to work out the values of p and v, so from point A. So first of all, we need to work out what the coordinates of point A is. So I'm going to zoom in so we can see that clearly. So we can see that the coordinates of point A, so zoom out so you can still see the graph axes. So we can see that the coordinates of point A, better. Okay, coordinates of point A is equal to, so its x value is minus 0.15 and its y value is looking like it's 2.18. So now we know the value of the x's and the y. Remember, our x is equivalent to log 10v, which means at point A, log 10v is equal to minus 0.15, and we know log 10p is equal to 2.18. So literally now to work out the values of p and v, this is based on your logarithm rules, so I'm going to rearrange them. So v would be rearranged to saying 10 to the power of minus 0.15, because based on this rule, just in case anyone's forgotten, log ab is equivalent to a to the power of x is equal to b. And then p is equal to 10 to the power of 2.18. So literally just put them into your calculator. And for your value of p, to three significant figures, you should get a value of 151, and your value of v to three significant figures should be 0.708. 0.708, yeah. Then for part B, it wants us to calculate the values of the constants C and D. So looking at the graph, I'm going to work out the equation that they've written. So that was the P is equal to CVD. Now, if we add logs to both sides here, just quick. So that would be log 10P is equal to log 10 CVD. Remember another log rule, which I'll write at the bottom here, trying to find space in case anyone needs refreshing. So if you have log AB, so log of two things that are multiplied together, doesn't always have to be log base 10, it goes with any base number. That is the same as saying log, well in this case log 10A plus log 10B. So you just end up separating them and you add them together. So then this can now be changed into log 10C plus log 10VD. And then the log 10VD, so again, if you ever have, so for instance, here, I'm just using log 10 because that's based on the question here, but again, it applies to all base numbers. So a to the power of x. Another way of writing that is x log 10a. So you move the power to the front. So then that is going to change. So it's going to be log 10p is equal to log 10c plus d log 10v. Now, as you can see here, it's kind of looking like our y equals mx plus c. The only difference is that the mx is there with the d times log 10v, and the plus c is our log 10c. So we can see that our y-intercept is c. So because y-intercept is always easier to work out, I'm going to do that one first. So y-intercept is here, where it crosses the graph. So I'm going to zoom in quickly just to see the value clearer. So I can see that's hitting at about 1.97. Yeah, I'd say about 1.97. So then because of that, also I'm gonna rub this all out since that question was already answered and create more room. So because we can see that our y-intercept, which is log 10c, is equal to 1.97, sorry, correction, log 10 1.97, as at that y-intercept, the p-value is 1.97 is equal to c. To work out what c is, we would literally just put that all into our calculator. So if you put that into your calculator, you should come out to three significant figures of 93.3 significant figures. So we've worked out what c is. Now, to work out what d is, again, we've said that it's quite similar to our y equals mx plus c. So our d value is our m, aka our gradient. So in order to work out the gradient, we're going to pick 2 points on the graph and literally you're just going to do your change in y by your change in x. So we already know the a coordinates, so that makes life easier. So we're just going to pick another coordinate as well. So I'm going to go with the one at the top. Again, it doesn't matter. The key thing is I would use any of the crosses that they've plotted on the graph to make your life easier. So, right, having a look at that point. So I'm going to zoom in again so you guys can see the coordinate. So that coordinate looks like the x value is minus 0. Looks like it's halfway between the 0.31 and 0.3. So I'm going to put 305. And then I'm going to put 2.4. Okay, so then now to work out change in y by change in x, the change in y is going to be the 2.18 from here, take away the 2.4, and then that's going to be over minus 0.15 minus minus, and remember because you're taking away and then there's an extra minus because the number is actually minus 0.305. So remember, if you've got two minuses together, it becomes a plus. And this is where sometimes some people can accidentally make mistakes. Okay, so working that out would, if you're all in your calculator, would give you an answer of to three significant figures minus 1.41. So then that is what we're going to write as our value for D. Okay, And then having a look at question 9a, so this is a complete new question. It just wants us to integrate this equation. So I'm going to rewrite it out. Okay, so integrating, literally the same as what we've just seen previously. So then add 1 to the power, divide that, add 1 to the power, divide that, and then working that out would leave you with 2x squared minus a quarter x cubed plus c. So this is a key point. When it comes to integrating questions, it's different if it wants you to work out the full equation and it's giving you some value to do that. But when it just says integrate, don't forget your plus c. Okay, so on to 9a part 2. It wants us to evaluate basically the equation that we just integrated, but it has definite integrals of 2 to minus 2. So then, because we've already integrated it, that's one step easier. So for now, we're just going to rewrite it out as this. So whenever you've got definite integrals, they always like to put this box bracket around it. And you don't need your plus c when you're evaluating and working out a specific area. So now we just need to substitute in the values. So it's going to be, so it would be whatever it is when you substitute 2 in, take away whatever it is when you substitute what minus 2 is. So with the 2, it would be 2 bracket 2 squared minus a quarter bracket 2 to the 4, take away, and then the 2 bracket minus 2 squared minus a quarter bracket minus 2 to the 4. Okay, so if we work that out, that would leave us with 8 minus 4 minus 8 minus 4. Haha, we have a problem. So this would result into 0. Then part B, it says using a sketch, explain why the integral in part A2 does not give the area enclosed between. So I'm going to sketch quite quickly. This is not drawn to scale. This is just 1 because they asked me to, and 2 because it will help you to understand what's going on. So remember, we've got a type of cubic graph, but because it's minus x cubed, it's a negative cubic graph. So I'm going to draw that the other way around. So that would be terrible. I'm going to do that again. Okay, better. So this is roughly what the 4x minus x cubed would look like. So then I'm going to draw the 0, the 2, the minus 2. So the reason why it's given us 0 is because we've worked out this area and this area. And the problem is that I'm going to highlight this one in red. Whenever you work out an area of definite integrals of an area that's below the x-axis, it usually gives you a negative value. And when it's above the x-axis, it's a positive value. And because it's an equal distance from 0 to 2 and 0 to minus 2, that positive and negative areas are going to cancel out to give us 0, which is why we've ended up with this result. So both areas for 0 to 2 and 0 to minus 2, wow, spelling, to minus 2 are the same. However, one is positive, I'll put positive, and one is negative, so they cancel out each other out, giving 0. Okay, so then in part C, it now wants us to find the area enclosed between the graph and the x-axis. And so in doing this, because we know that based on our sketch, we can't use the definite integral range from 2 to minus 2. We're going to have to work out the area of 0 to 2, work out the area. So we know the area of 0 to 2 is literally going to be the same. Is the area from 0 to minus 2. So work out one of the areas, then multiply that by 2. And that's going to give us the whole area enclosed, because then it won't include the cancelling out. So what we're going to do is we are going to integrate again. So we're not going to do anything different. The only difference is my ranges have now changed. And the integration, we already know what it is because we worked it out high up here. That bit's not going to change. So it'll be the 2x squared minus, I'm going to rewrite that so it's not as messy, minus a quarter x to the 4. So now inputting those values, we would end up with, again, the 2 squared that we worked out up here. But the only difference is it will be taken away from 0. So then that would leave us with the 8 minus 4, which I'm just going to rewrite as 4. And anything take away 0 is 0. So we know that an area there is 4. So because we know that the same area, I'm going to add the 4 plus 4 together, and you would get a total area of 8. And I hope that makes sense. Then having a look at question 6, it's given us this graph, and it says that the region enclosed between the curve, the x-axis, the lines, x is 1, so I'm going to imagine this is x is 1. It doesn't need to be drawn to scale. So x is 1, and x equals a, bearing in mind that a is greater than 1. So let's say if a is here, again, not drawn to scale, just so you understand. So it wants us to work out the area between the x-axis, the curve, and those two lines. So this area. So in order to work out area underneath a curve, we need to integrate the equation. So we've been given the equation. Again, for this one, I'm also going to push it to the side to create more space for us to understand what is going on. And space for me to work it out. Okay, so it's going to be y is equal to 2 over x root x. So then in order to now integrate that, I'm first of all going to have to rewrite what I have. So first thing is I'm going to bring 2 out, and that's going to leave me with 1 over x root x dx. Next step is I'm going to rewrite root x as to the power of minus a half. Sorry, to the power of a half. So that will be, rather than that, it will be times x to the power of a half. And then I'm again going to simplify this even further, and that would leave me with, so if you've got x times x to the half, remember you add the powers when you multiply indices, so 1 plus a half, which is just 3 over 2, aka 1 and a half. So I'm going to write as 1 over x 3 over 2 dx, and again, if you have 1 over something, you can change that into a negative indice. So now I have this, I can integrate this. So then add 1 to the power, so that'll be to the minus half, and then that'll be divided by minus half. So then we know that if you divide by minus half, dividing by fractions, basically flip the fraction at the bottom. So now it'll be the same as like multiplying by minus 2. So it'll be minus 2x to the power of minus a half. And then multiply the 2 on the outside to what's inside, and that would leave you with minus 4x to the power of negative half. Okay, so now we've integrated. The key thing here is that we know the area is equal to 3. So remember, the area is between the limits of a and 1. So I'm going to put the brackets of the limits, which I could have put initially as well. a and 1, a and 1, a and 1, so a and 1. And then now to do that, I'm going to substitute them in. So that would be minus 4. First of all, before I even substitute anything in, I'm going to rewrite it so it's nicer to deal with. Okay, so that would be a and then 1, so it'll be minus 4 over root x. That's another way of rewriting that. So then I would have minus 4 over root a minus, and then substituting 1, so then minus 4 over root 1. Minus 4 over root 1 is 1, so that's just really going to cancel out to be minus 4. So we know that bracket is going to be minus 4. Minus, and then remember it's minus 4, so minus 4. 2 minuses become a plus. And remember, because it's told us that the area is equal to 3, this is all equal to 3. So now we just need to rearrange this to work out what a is. So then in terms of working out what a is, minus 4 over root a would be equal to minus 1. And then to work out what a is, well, root a is the same as minus 4 divided by minus 1, which is positive 4. So then to work out what A is, we need to square those sides. So 4 squared, which would be 16. So we can happily say that A is equal to 16. Okay, then moving on to question 8. I'm just going to rub it out here again so we have more space. So question 8a wants us to find the value of P and find the value of Q. So what we're going to do is, first of all, we are going to differentiate it. And then by differentiate it, we're going to substitute the coordinates of the points that they've put. And then we're also now going to substitute the coordinates into the initial equation. And we're basically going to solve this by simultaneous equations. So rather than me explain, let me actually do what I'm talking about. Okay, so I'm going to rewrite the formula. Okay, so then dy by dx would be differentiated, it would be 3x squared plus 2px plus q, and then the minus 45 will disappear. And then if we now substitute in the values of when x is 2, that would be 3 and then 2 squared plus 2p times 2 plus q. So then that would end up being 8. Not 8, sorry, because 2 squared is 4 times 3 is 12. So then 12 plus 4p plus q is equal to 8, because we know the gradient, aka dy by dx, is equal to 8. So now that we have that one formula, oh wait, I need to simplify that even further. So then 4p plus q is equal to, so take away 12 minus 4. Okay, so now we have the first equation. I'm going to substitute the r is equal to 2, 3 into the second one to work out our second linear equation. So then our y value is 3. So then 3 is equal to 2 cubed plus p 2 squared plus q times 2 minus 45. That would end up giving us 8 plus 4p plus 2q minus 45, and then that's equal to 3. Simplifying this even further, that would leave us with 4p plus 2q, so 8 minus 45 would leave us with minus 37. So then that's equal to 3, and then to simplify that even further, we're going to add 37 to both sides, so 40 would equal to 4p plus 2q. Okay, so now we have our two equations. And great that with simultaneous equations, life is so much easier when two of your letters are already the same. So we've got 4p and 4p, they'll cancel out. Then q minus 2q would leave us with negative q. And then minus 4 minus 40 would just be minus 44. So then we know that q is equal to positive 44 because the two negatives will cancel out. Then we're going to substitute our value of q into any of the equations. So we can even substitute into this one here. So then 40 is equal to 4p plus 88. Take away 88 from both sides, you're left with minus 48 is equal to 4p. And then divide both sides by 4. You end up with p being equal to negative 12. So we've worked out that p is equal to minus 12, and we worked out that q is equal to 44. And then the last bit is now the area enclosed between the normal of the curve at r and the coordinates of the axis. So I thought the best way to show this was to sketch out, just so you guys understand. So this time we're going this side, we're putting the question here, changing it up. Okay, so I'm going to quickly sketch a graph on the top. Again, this is really not drawn to scale, this is just for the purpose of your understanding. So let's say this is our graph. Remember normal, and let's say this is our point R. Remember your normal is perpendicular. So let's stretch out that y-axis. Your normal is perpendicular to the graph. Yes. And your tangent, remember the gradient of the tangent is parallel. So that's why the tangent gradient usually is the same as the gradient of from the curve. and the normal one is always the negative reciprocal. So first things first, because it's involving normals, and we know that dy by dx is the same as our gradient, we can happily say that dy by dx of the normal is equal to minus 1 over 8, because we've worked out the negative reciprocal, aka flip it and stick a negative in front of it. So now to work out the equation of the normal, we know the equation of a straight line is y equals mx plus c. So the gradient is minus 1 over 8 x plus c. So then now to work out the full equation, we're going to substitute our coordinates of r, which is 2, 3, to work out what c is. So then that would be 3 is equal to minus 1 over 8 times 2 plus c. And then that would be 3 is equal to negative a quarter plus c. So c would be equal to 13 over 4, because we added a quarter to both sides. So now that we have that, we can happily say that our equation of our normal is y is equal to negative 1 over 8x plus 13 over 4. So now we've worked out the equation of the normal. We can see that the normal intersects the x-axis from our sketch, intersects the x-axis. And we know at the x-axis, your y value is equal to 0. So by doing that, we can work out what that point is. So to do that, we need to substitute y is equal to 0 into the equation for the normal. Then we're going to rearrange it. So then minus 13 over 4 is equal to minus 1 over 8x. And then you would therefore do minus 13 over 4 divided by minus 1 over 8. So to do that without a calculator, remember, if you divide fractions, it's the same as multiplying them when they're flipped. So that'll be multiplied by negative an 8. And then by doing that, you end up with minus 104 over 4 is equal to x. Removing this equal sign so it doesn't confuse anyone. 104 is divisible by 4, gives us an answer of negative 26. Sorry, not negative 26, it will be positive 26, because the minus 8 times the minus 13, two negatives multiplied each other, gives you a positive. So we know x is equal to 26 at that point. Okay, so now that we know that point, now the last thing that we need to do is, well, not last thing actually, I lie. What we can do is we can kind of form like a mini right angle here, because we know at that point of r, x is 2. So we've got the difference of 2 and 26. I really did say it wasn't drawn to scale, which is fine. So we're going to use Pythagoras and work out the area of that right angle triangle. So not Pythagoras, sorry, just use the half base times height. So area of a right angle triangle is half base times perpendicular height. So it would be half times our base, which is the difference between 26 and 2, which is 24, times the height, which the height would be that point on the y-axis, which would be 3. So half times 24 times 3 would leave us with, let me roll up the page, 36. So we can happily say that the area of the triangle, yeah, better. The area of this triangle is 36. So I'm just going to wrap this out. So we have, again, more space. Okay, so now we know that the area of the triangle, we need to work out the rest of the area, though, however. So in order for us to do that, because it is the area enclosed between the normal to the curve at r and the coordinates of x. So what we're going to do for the rest of it is we really need to integrate. So we're going to integrate now. And this time we're going to integrate to work out this area. So, okay. All right. So in order to do this, the reason why I'm picking those areas as well is because it specifically says the coordinate axes. It's different because it's not like previous questions where you'll just see specifically the x-axis or the y-axis. So it's basically all those areas. And so to do that, at this point, we can see that y is equal to 0. It's the y-axis. So x is equal to 0 at the y-axis. So if I move down. Okay, so I'm going to draw my definite integrals and then the equation. So this time, because we already worked out what P and Q are, so rather than plus px squared, it's going to be minus 12x squared. And we worked out what Q is, it was plus 44x minus 45. Okay, so we need to integrate. So now if we integrate, then we x to the 4 over 4 minus 12x cubed over 3 plus 44x squared over 2 minus 45. Okay, so now that we have this, I'm going to move the page so we have more space. Okay, so now that we've integrated, I'm just going to simplify this integration a bit more into a quarter x to the 4 minus 4x cubed plus 22x squared minus 45. Okay, so now, oh, and then 45x. What's add to x to 45? All right, so then now that I've done that, substituting the values, remember you're going to do all of that of 2, take away 0. So then that's going to be 2, I wrote 2 up there. So a quarter times 2 to the 4 minus 4 2 cubed plus 22 2 squared minus 45 2. Okay, so now that we have that, we need to literally work this out. So 2 to the 4 is 16, a quarter of 16 is 4, 2 cubed is 8, times 4 is 32, because this is a minus there, and then 2 squared is 4, times 22 is plus 88, and then 45 times 2 is 90. So now that we have that, we need to simplify this. So that would all simplify into 2, because 4 minus 32 is minus 28, 88 minus 90 is minus 2, and then that would be minus 30. So again, the only reason why we have a negative answer is because if I do this, okay, yeah, so better. Okay, so the only reason why we have a negative answer is purely because some of the areas underneath the x-axis, which I briefly explained before, but the total area is 30. So then it would be the 30 plus the 36 from the area of the triangle. So total area enclosed would be 66. So that's the end of differentiation and integration for A-level Maths AQA. Please do comment down below if there's a next topic you want. If not, then I will just pick one at random for A-level Maths and hopefully we'll post 2 more for AQA this week. Thanks for watching.